Hello everyone, welcome back. Today we're going to be looking at torque and inertia. So, by the end of this lesson, I'm now going to show you some targets for the end of the lesson so you know where it's going and what you should know. So, you should know how to describe and explain torque and inertia, and also understand the equations T equals Fr, T equals Fr sine theta, and T equals inertia alpha, and inertia equals mr squared. So torque, let's take a look at this diagram, this very well drawn diagram I've drawn up here at the top. So this is supposed to be a door from a bird's eye view, okay? So the radius I've highlighted in red. So let's take a look at, if I present a force here of 10 newtons, let's say, it's relatively easy to push around. And if I present the same amount of force of 10 newtons closer to the centre of rotation, then that means that, well, you know how it feels. It's harder to push the door the closer it is to the hinges, right? And it's easier to push it when it's more outwards, away from the centre of rotation, okay? So it's the same force, but it has a different turning effect. So if you push it from the outside with 10 newtons, it will turn more than it would if it was pushed with 10 newtons closer into the centre of rotation, okay? And that's what torque is. Torque is the turning effect that a force has on an object, okay? So it is sort of a force. It's the measure, I'm going to repeat it, it's the measure of the turning effect that a force has on an object. And at the bottom here, it's just the formula for when a force is applied at an angle other than 90 degrees. Okay, so that's not hard. Also, torque causes angular acceleration, so torque must be a force of some sort. It's just a little bit different. It's the angular version of force. So we've got Newton's second law up here, right? And so if we rearrange it, which I've shown you here, we get T equals I alpha. So this last part, mr squared, turning into I, you haven't been taught yet, but I'll go on to that now. But I is actually inertia, okay? Now, the moment of inertia. The moment of inertia depends on the mass of the object as well as the distribution of said mass. So the moment of inertia is the measurement of how reluctant an object is to changing its state of motion. So think about this. Inertia, if you have a huge metal ball, it's really hard to try and get that to move, and really hard to try and get that to stop. So it's harder to change its state of motion rather than a really small metal ball, okay? So inertia is how reluctant something is to change its state of motion, and the moment of inertia is how reluctant an object is to change its angular state of motion. Now, sorry, pardon me. So I've drawn two rods here, one here and one here. They've both got the same mass, but one has a radius of r and one has a radius of half r. What does that say up here? I can barely read my own writing. So it's the, what do you call it? The torque. So when we use the torque here, we always use it from the end, okay? For inertia, that is. And this is the centre of rotation here, okay? So using the equation I equals mr squared, if the radius is decreased and the mass remains constant, that means that the inertia must decrease for the radius that's decreased. So it's easier to move an object of the same mass if it's closer to the axis of rotation. Okay? I hope you're understanding this. Now, if you don't understand it, feel free to watch it back a couple of times. YouTube allows that. It's not illegal. And so, if the inertia decreases the closer the mass gets to the centre of rotation, that's the distribution we're talking about now. If the mass is distributed closer to the centre of rotation, that means that less torque is needed to move the rod. Right, this was a shorter video than usual, but it covers the main aspects of it. Don't use this as your only revision material. This is just one of many you can use. Go on to Scholar, go on to, well, you can't use BBC Bite Size for advanced hires, which is a bit of a shame, but Scholar helps you with everything you'd need to know as well. So thank you for watching today. I hope you learned something. I'll see you next time. Bye.